can probably see why this is called a double inequality, all right? So when you see double inequality referred to, this is it. Previous problem. Oh, I see what you're saying. Absolutely. Oh, yes. We're ready to do that. Notice that this involves two concepts. Number one, a double inequality. And number two, a fraction. So don't forget that. Hey, look at the double inequality. This thing is greater than -4. I can say -4 is less than that. And this thing is less than 4. So it's making two statements. This is basically an and statement. That's true, and that's true. So we put them in a compound mathematical sentence, call it a double inequality, basically saying two things about it. 2x minus 3 over 3. Yes,
ma'am. Will like with the side be like fractions, something like that?
Yes, sir.
Like what if the sides ended up being fractions? This is just a hypothetical.
If they ended up being fractions, no big deal.
Okay.
We'll look at it. Yeah, and they will at times end up being fractions.
Okay.
In this case, I think.
It is.
So let's look. Hey, what was your suggestion?
Multiply both sides by 3.
Notice you said both sides, but actually you meant
all three sides.
Yeah. Hey, we typically say multiply both sides by 3, right? Because there's two sides. I got 3 parts here. So be sure to multiply all 3 parts by 3. That's what you meant. And you're absolutely right because we got a denominator of 3. Multiply everything by 3. Hey, still inequalities. I can multiply both sides by a number, and I'm choosing to multiply by 3. And solving a double inequality is exactly the same as solving an equation and solving a regular inequality. I want x by itself.
You add 3 on both sides.
Okay, get rid of the 3. So add 3 and all around, please.
Divide the 2. And then you divide the 2.
Then you divide the 2, and there's the fractions that you wished for. So negative, you can say 4.5 is less than x, less than 7.
Do you have to put it in decimal form? Can you just leave it in fraction form?
You can leave it in fraction form. Okay. Remember, it's going to be multiple choice, so you got to look for what's there, right?
Gotcha.
Would web assign want it in fraction form, or would they want it in decimal?
I think we've tried it both ways, and I think either way works. Yes, sir. Interval notation? We sure could. X is in between -4 and 7.5. So how would I need to... Hey, a good way to do it might be to graph the thing first. If I have the graph, the interval is...
Not interval, I meant the graph.
You meant the graph? Okay. Sure. Notice that your physical letter X is in between -4 and 7.5. Literally, your X's, all your solutions are between -4.5 and 7.5. So all your X's are in between those two values. And what do I use for my end markers?
Parentheses.
So you can probably see what the interval is going to be, right? -4.5. All right. Here's where we enter a realm that some of you are not going to be familiar with. It's the realm of absolute values in inequalities. Okay? Some of you may have encountered it before, others of you might not. But we're going to be looking at this in two different ways. First of all, an absolute value is less than a number. Then we're going to look at absolute values greater than a number. They work differently. So we're going to consider them separately so that when you make your 3x5 card out, you'll have two ideas. Absolute value is less than a number. Absolute value is greater than a number. Let's do less than first. I have absolute value something less than a number. For instance, number 57 on page 147. All right. If I'm going to understand where my x's are, I need to get rid of that absolute value symbol. That is confusing, to say the least. So my next statement will be free of sans absolute value numbers. And it is going to be, ladies and gentlemen, a double inequality. Which you're already familiar with. Yeah, we'll see. Yeah, I think you're right. Here's the way it works. Whatever's in your absolute value marker, it's just x in this case, goes in between this number and its opposite. So it goes in between 5 and negative 5. And the arrows always point to the smaller of the two. Hey, there it is. That's it. We're finished. Ta-da. That's the double inequality that defines these x's that we're talking about. There anything in between negative 5 and 5, not including those values.
So if 5x, or in the absolute value, we would be 5x in the middle, whatever is in there.
Well, we're still going to have to get x by itself, and we'll do that in a second.
But when you start,
Yes. Whatever's in the absolute value goes in the middle, surrounded by the number and its opposite. So can you look at that set and tell what numbers are in it?
The numbers between.
Is negative 4 in that set, for instance?
Yes.
Okay, so let's take negative 4 and put it back in our original statement, see if it makes sense. Absolute value of negative 4 is that less than 5?
Yes.
Yeah, okay, I see it work. And pick a number on the outside, like 7. It's not in the set. Absolute value of 7 is 7. 7 less than 5? No. And I should expect numbers outside the set not to work. That's the concept. Well, it's easy. Let's try one that's a little bit more sophisticated, like 63. Understand, I haven't finished solving my equation or my inequality until it's x all by itself. So we're still going to start off the same way. Whatever's in the absolute value is in between the number and its opposite. Arrows always point toward a smaller number. What you going to do now?
Add 20 to both sides.
Yeah. So it's like we saw the double inequalities. I got to get x by itself in the middle, so add 20. Not once, not twice, but 3 times less. And there's your set. It's anything in between 14 and 26. Does it include 14 and 26?
Yes. Yes.
How do you know?
Because
Equal
less
to
than equal
signs, if it
to.
includes it, that means I have brackets on my number line and on my interval. Is that okay? So you got an absolute value is less than, it translates to a double inequality. Whatever's in the absolute value goes to the middle. The number and its opposite go on the extremes. And the arrows of inequality always point toward the smaller of the two numbers. Absolute value is greater. And by the way, this guy graphs like this, right? Mm. 14 to 26. All right, concept number 2. Absolute value is greater than a number. This, by the way, is going to translate to an OR statement. Now that we mean a union, right? Let's look at an example like 58. Let's start simple. Number 58. So this is going to translate to 2 inequality statements. This or that. Okay, so it's going to be a this or that statement. The this statement is utterly simple. You just drop the absolute values. That's how you do it. So it's going to be x is greater than or equal to 8. That's my first statement. See, I got it? Just drop the absolute values. Now please keep in mind this method works with greater than. Absolute value is greater than. They're 2 distinct ways of presenting the ideas, so be sure to keep these guys separate. All right, the second statement starts out the same way. But I reverse the inequality, and I take the opposite of the number. So these 2 things are changed. So far, so good? Hey, it's an OR statement. That means I put both these guys on the same graph. So first of all, x is greater than or equal to 8. Let's see, here's 0, here's negative 8, here's 8. X is greater than or equal to 8 is this right here. Right?
This,
Same graph. X is less than or equal to negative 8 is this guy right here. Okay? So supposedly, anything that's highlighted, that's shaded in, will give me a true statement on my original expression. Let's try it out. Like 10 is shaded in, right? Is it? 10 shaded in. So absolute value of 10 is 10. That's greater than or equal to 8? Yeah, true statement. Hey, negative 13 is in the set. Absolute value of negative 13, that's 13. That's greater than or equal to 8. Yeah. Hey, pick something that's not in the set. 0 is not in the set. Absolute value of 0 is 0. 0 is greater than or equal to 8. Eh. Okay. So I have visual evidence that the stuff in the shaded area gives a true statement to this original expression. The stuff that's not shaded would give a false statement. Do you want a little bit more bite? Like